Hello everyone, welcome back to the session on your Unit 4, Part 1, that is nothing but physical devices and end system. And I think this is the third session with respect to this particular topic called as physical devices and end systems. So in the previous session, we discussed about something called as in the first session related to your physical device and endpoints, we discussed about the introduction, right? The introduction of your physical devices where we have seen some four different type of modules with respect to your IoT. So what are the modules we have seen is something called as sensing. Then we have seen acquisition. Followed with that, we discussed about something called communication. And the last but not the least, what we discussed is something called as analysis, right? Analysis. So if we talk about sensing, we discussed that we different type of sensors can be uploaded directly connected to your IoT device, and with the help of that, we can perform different operations. Then we discussed about acquisition. Now, whatever the data that has been sensed using the sensors, here we use basically sensors. So using that sensors, whatever we are actually sensing it, based on that, what are the physical activity that need to be taken place can be taken with the help of this particular acquisition. Then we discussed something about communication, right? In communication, we discussed how the data that has been sensed by the different sensors is actually communicated to either to something called as other neighbor nodes, either to neighbor nodes or to the cloud storage. So basically we can transmit there. And then finally, whatever the data we are storing in the cloud, we need to perform some kind of analysis using some different kind of latest technologies. What we have, something like Hadoop, we can use cloud computing or machine language. So we will be developing different algorithms. So using that algorithms, using this particular techniques, we'll develop it, and that algorithms will implement on the data whichever we are storing in the cloud. And based on that, we'll perform different operations, or maybe we will be predicting some values with respect to your temperature, humidity, and all. For example, if we talk about weather monitoring sensor, we'll be trying to predict the different temperatures. Okay, so what will be the temperature? What will be the climate of tomorrow? And that kind of things we are going to sense it up using that particular thing. Okay, so basically the first thing what we need is sensors. Using sensors, we have to get the data, and on that data only we are going to perform different applications. And in the second session, that is session 2, we discussed about that hardware devices. So what are the hardware devices we use? So in this, the most popular what we used is Raspberry Pi. We discussed about Raspberry Pi, right? In this, we have seen different, we have different versions here. Okay, the latest version we also discussed, that is module 2, right? Model 2, what we have, and that particular Raspberry Pi we can use it up, which uses 700 megahertz. Okay, million instructions per second in a cycle, it can perform the operation. So that we have seen it, and with respect to that, we have seen the model. We have actually discussed about the model of the Raspberry Pi, which actually consists of some pins, around 26 pins that we have discussed. Apart from that particular pins, we also discussed about how this particular model is consists of other things like HDMI. It also consists of RJ45 jack, that is nothing but your Ethernet, and then we have USB, right? USB of type 2.0 that we have discussed. And apart from that, we also seen something called as RAC jack. That is nothing but Radio American Corporation. So they are the one who gave this particular thing in order to display the videos. Same way by video by audio connector also we have also seen with respect to your Raspberry Pi. So that we have covered in the session 2. In today's session, we are actually going to discuss the further. Actually, till now, whatever we discussed is related to your hardware part. Now we are going and or we are entering into something called as the programmatic part. Now let's see how we can using these devices. Once these devices are connected for different purposes, how we can provide the programs, and using that program, how we can implement our applications, that we are going to see in this. We are going to basically discuss about some simple applications. Okay, since it is the beginning of your IoT, so we'll be going through some physical applications, some simple applications like blinking of a light and all. So previously, if you look at in this particular slide, so we have already covered something. Something like basic building blocks of IoT we have already covered. Then we discussed about something called as Raspberry Pi. That is what we had discussed. Today's session we will try to cover the remaining portion what we have here. That is nothing but your interface. Anyhow, interface I have covered in the previous session when we were discussing about the pins. I told you that 4 different types of pins we do have, right? Serial, SPI, then I2C. Okay, and then we have something called pulse modulation with PMW. Okay, so standard pins. So in this we have software related and hardware related. Okay, software is present in all the pins. Hardware related, we discussed some 4 different types of pins, right? And same way I2C, we have seen some pins which are supportable for I2C. What do you mean by I2C? I think if people are familiar now, I2 is nothing but double I, inter integrated circuit. It is used to connect the different other sensors to a Raspberry Pi. For that we use this I2C. Then we have SPI. I think you people know. Okay, we'll discuss this serial and SPI in this particular session also. SPI is nothing but serial. It's a serial protocol interface. Okay, we'll see the different form of it. It is related to it. So coming to the serial, we discussed that we have 2 pins, TX and RX. TX is used for transmission and RX we use it for receiving the data. And basically based on that, these are a serial pins. Whatever we have, we use it in SPI. Okay, and in the SPI we have again 4 different types of pins. That are already discussed in the previous session. Again, we are just going to revise this in this. So we have MISO, then we have MOSI, then we have CE0, CE1. Okay. Apart from that, it has also has something called CLKS, synchronous clock. So sorry, serial clock, CLK. So that we have already discussed, and this is with respect to SPI 0 and SPI 1. So we have 2 types. So we have different pins for SPI 0 for this, and same way for SPI 1, we have different pins for this particular scenario. So based upon the requirement, we might be using any one of the pins, and we will be performing our or executing our application. And next we are going to discuss about here something called as a RAS programming part. So this is most important here. You will know how to write the programs and how to execute the programs. Followed with that, what are the other IoT devices we do have with respect to Raspberry? We know basically is Arduino. Well, we are not going to discuss that. We will be discussing a model similar to that of your Raspberry Pi. So we have 3 different types that have been actually discussed in this particular subject. So that we will be discussing here. Okay, so Arduino, if you are very much familiar, if you are interested to know more about this particular board, I suggest that you people please prefer for Arduino also. Arduino is one of the best device what we have. Mostly we use it in our projects and all. So I want you, if you have time, you can spare some time in order to know or discuss about the different boards what we have in Arduino. Okay. Now coming to the interfaces. So basically, Raspberry Pi basically has, as I discussed earlier, we have 3 type of interfaces here. So we basically have 3 types. That is nothing but your serial. Then we have SPI as I told you before, and then we have I2C. So that only we are going to discuss here. And as I told you, serial will have 2 pins here, RX and TX. RX is used for mostly for receiving the data from the other devices, whereas TX is used for transmission. So mostly these 2 pins, whatever we are using it, that pins are used only for communication purpose. And if you want to know which pins actually used for receiving a TX, I'm not going to say here. You please watch the previous video so that you can get an idea which pins are actually supporting it. Basically, if I'm not wrong, it is 14 GPIO, general purpose input output pin 14, and here GPIO 15. So if you want to get a clear clarity related to what pins are supported and which pins belongs to which particular functionality, you please go through the previous video. So this is related to that. Okay, so 14 and 15 are comes under this particular receive and transmission. Mostly used for communication between serial peripherals. Serial peripheral nothing but the other devices which are actually connected. And the next one what we have is SPA, serial protocol interface. Now this actually uses something called as asynchronous serial data protocol. It uses a protocol. SPA uses a basic protocol. We call it as asynchronous serial data protocol. Means the data will be transmitted. Data is transmitted serially. Data is transmitted serially. Okay. So, and it is mainly used for communicating purposes, and in between one or more peripheral devices, means more than one device or more than one different type of sensors, we can provide communication. In order to provide communication only, we are actually seeing it. Okay, and apart from that, we do have, let me erase it up. It's looking somewhat, yeah. Next, here we need to focus on, as I told you in the previous slide, that this SPI is having again 4 types that I already explained you. Well, what are the 4 types in the previous session itself? We discussed about MISO, we discussed about MOSI, CE0, then we discussed about something called CE1. That only we are going to discuss here. Let me explain them what exactly that means. So here, the first one, actually what it means to say that basically SPI will have one master device. Okay. Basically, SPI will have one master device and multiple slave device. This is something you can imagine. Okay, just illusion you can create it that something master device is nothing but which is inbuilt in the board. Okay, like that you can imagine inbuilt in board. Whereas coming to this particular multiple slave is talking about these are the sensors which we have connected to this particular device. So basically master means the one who will be transmitting the data, slave is the one who will receive the data. So and these are the sensors which we are going to integrate with the board. These are the sensors which we are going to integrate with board. These are not inbuilt. Okay, not inbuilt. Okay, inbuilt means it comes with the device itself. That is your Raspberry Pi. But here, these sensors we are actually integrating, means we are connecting to the Raspberry Pi board. So that is what you can call it as slave devices. Master device means this is inbuilt. Within the board only you will be having that particular component so that you can use it. So that in that way you can understand or you can imagine it. So we will be having basically one master device and there will be more than one peripheral devices. Now, basically, as I told you, there are 5 types. So let's see what are the different types we have. It's a very easy to understand. So the first one, what we have here is something called as MISO. So MISO is nothing but master in slave out. Means it is a communication channel which is used for transmitting the data to peripherals. Means from the inbuilt component of a Raspberry Pi, you are transmitting the data towards sensor device. Sensor device. So that is what we call it. It is a master line for communication, sending the data to the peripherals. Okay, so master will be transmitting to the slave. And the next one, what we have is MOSI. MOSI is nothing but most master out slave in. In this, it is also another communication channel in order to transmit the data. But this time it is reverse. From the sensor device, the data will be transmitted to the Raspberry Pi inbuilt component. That is what comes under MOSI. So it is a slave line for sending the data to the master. Then we have SKC. As I told you, it is nothing but a serial clock, what we actually use. Why we use this is for providing synchronous. What we said here, we said that this particular uses a asynchronous serial data communication. But here, whenever we are transmitting data from sensor to data, let us suppose client to server or something like that, you can imagine. Whenever you are transmitting data in between communication takes place, whatever the data is getting transmitted, it should not collide with each other. It should not collide with each other. And how we can provide that means it can be done only when we are synchronizing the data. Means at a time only one process is allowed to enter. I mean, in operating system, you might have heard that at a time one process can enter into the critical section. Means whenever one particular process is executing something important, then no other process is allowed to execute in that particular section. Same way here also synchronizing data is nothing but when one of the process or one of the device is sending the data, no other device should send the data until it reaches or it transmits it. Okay, so for that purpose only we are using this clock, and using this clock it can determine when the other device can transmit the data and when not. And next we have something called CE0, that is nothing but chip enable 0. It is for something like enabling or disabling the devices. Okay, and this is another step for enabling and disabling the devices. So basically these two types are used for, since we are we are actually integrating multiple devices, right? So sometimes we may not want that particular device to use for particular situations, but we want that to be get connected to this particular thing. So there we come across something called as enabling and disabling. So we can enable one particular device or we can simply disable another device. The last but not the least, I2C, inter-integrated circuit, and basically it is used for connecting hardware modules. Since the name itself you might have understood. So this is representing inter-integrated circuit. So what is the main purpose of inter-integrated circuit? It allows, so nothing but it will make sure it's a hardware. So it is used for connecting hardware modules, and it will use for transmitting the data between two pins. We have two pins. This is pin 1, pin 2, and this pin 1 is for data transmission. We call it as data line, SDA, and another one is SCL, clock line. serial clock line. And what about this one? SCA is nothing but serial data line. So let me write the synonyms. Okay, here, yeah, SDA is nothing but serial data line. And whereas coming to SCL, it is nothing but it's a serial clock line. Okay, so in between to transmit the data, we use this particular integrated inter-integrated circuit. I hope it's very clear here. That is related to your serial interfaces, what we do have. And the next thing, what we are going to see here is something example. So let's, without wasting any time, we enter into the programmatic part now. So the first thing I'm going to show you here is nothing but a simple program for turning your LED on. So we are going to turning a LED bulb on. Okay. So this we are going to do it using your console application. That is console, I think you people know very well. This is nothing but your command line. So how we can do that? This is like, okay, this is a program what we have it. So this is a program you people are going to write in a Raspberry Linux. Raspberry Linux, which we have seen in the previous session how to install it. So within that Linux command line, we are going to use this particular concept. So if you see the first step, what you have is echo 18. Now this 18 is the pin where we will be connecting that particular LED. Okay, so this is the output pin. We have around 26 pins. If you remember, we have around 26 pins. Among that pins, we have output pins, we have power pins, we have ground pins, right? So among those power pins, I mean output pins, whatever we have, one of the pin you can use it for presenting. Input output pins, whatever here, general purpose input output pins. And among them, 18 is a general purpose input output pin. So I'm using this as an output. Now in this, the first thing what you are seeing, this class/GPIO export means what does this particular line indicates it? It is trying to export the libraries for creating a node. Creating a node for what? For GPIO 18th pin. Okay, now I wanted to use the 18th pin in order to represent the output. So this is the one is saying that we are going to export the libraries. Okay, so in order to export the libraries from internally, we are going to use this particular command. So from the GPIO library, is asking you to import the libraries in order to create the nodes. So that node will be created. So 18 node will be created and now we can set it up. So we are going to show the output using this particular pin and that is what is representing here in the second one. So we are directly entering into this particular directory. Now once you have created a node, we have actually created a node for this particular pin 18. Now we have to set that particular pin, that what functionality this particular pin we are going to use. So here we can see the next step, echo out. So it means we are setting that pin 18 for output. You are indicating, you are telling the Raspberry Pi that I am going to use this particular pin as output. Okay, this particular pin 18, GPIO pin 18 as output to display the output. Now, after you are setting it, we can simply give echo 1, 0. So actually this is a value here. This value can take only two values. Okay, 0 and 1. 0 represents low for low voltage and 1 represents high voltage. So whenever you are setting the value echo 1, automatically the LED will turn on. So this is a simple example for turning your LED on. That is what we are doing it. So whenever you give echo 1, automatically the light will get turned on. But whenever you are giving 0, automatically it's low voltage, so automatically that particular LED will be turned off. So this is a way simply we can write a program. So this is a simple, I will not say that this is a program, rather it is simply a code. A simple command line code in order to make an LED turn on or off using a command line. Now after this, let's enter into the programmatic part. So let's see how we can write a program in order to make the same thing happen using Python programming. Now this is the diagram. Okay, this is the actual logic what we have here. So the very first step what you have here, basically you people have a good knowledge related to programming concepts. You know that the first steps initially will be importing the packages. So here we are importing a package called rpi.gpio as GPIO. So what we are doing, we are using a alias name for this particular package. We can't use this again and again. So for this, I am creating an alias name GPIO. So whenever I want, I can use simply this alias name, okay, shortcut name. Here RPI is nothing but this is the module. This is the module used, okay, and within this particular module, we have GPIO, and using this module, we are trying to import the libraries. We are trying to import the libraries of GPIO. We are going to import all the libraries with respect to this particular GPIO. And apart from that, we are also going to import another statement, okay, import another package, something called as time. Okay, let me explain you what we are going to do exactly in this particular scenario. Actually, we have a bulb here, and this bulb we are connecting to a Raspberry Pi. Now we will be writing a code. That code we will dump into this particular thing, and what we are going to do is we will be turning this particular LED on. So if it is an off state, we will make it as on. Once it is on, we will allow that particular bulb to be in on state for 1 second. After 1 second, immediately the bulb should be turned off. Again, after 1 second, the bulb should be turned on for 1 second. And again, after 1 second, it should be, on. And again, after 1 second, it should be off. This is the way it actually works. Okay, yeah, it will keep on working. It will not stop because we are writing that particular code something in a looping statement, which is always true. This is the infinite loop. This is a infinite loop. So it will keep on executing. This particular statements will keep on executing like this until and unless you are resetting that particular Raspberry Pi board. Till then it will keep on executing the program. So the very next step what we have is gpio.setMode. Well, why we are setting this mode? Well, we are importing this particular package. Okay, let me erase it. Okay, we'll write it here. Since we are importing a package called GPIO, this is actually represent two different type of systems here. Something BCM system. I think if people are not familiar with this. Okay, let me explain. Let me take some time. So another one, another system, what it actually supports is something called as board. And if you talk about BCIM, okay, so this BCIM can be used at a time. Okay, any one can be used at a time. So both the systems we cannot use it. These two, among these two, only one at a time we can use it. So if we talk about board here, we can directly give pin numbers. Using pin numbers, you can set the target. Whereas coming to BCM, here what he's saying is Broadcom GPIO numbers. This is BROAD Broadcom GPIO numbers. So basically this one, if you talk about, this is pin numbers, this is your GPIO numbers. Both are different, okay? So at a time you can use it. So here we are actually setting it as BCM, means we are using GPIO numbers in order to set the mode. So what mode it is going to be. And then we are setting the pin from where I want the output. So if you see here in the console, we simply wrote here that 18 is the pin which from where I wanted to execute it. If you can see here, 18 is the pin from where I'm going to execute it. But here I have to set the pin. First I have to set the mode, which particular system I am going to use. Because this GPIO supports two different type of systems. One is BCM, another is board. Okay, so this board is nothing but pin number. So it uses pin numbers to represent, whereas BCM, well, both are doing the same functionality. But only thing here is that if you take BCM, then you have to again specify the number that which particular pin you want to use as an output, that you have to specify. Here what we are doing, rather than that, we are directly indicating that within the board use the pin number 18. So here it will use pin number and directly it will display. That's what we are doing. That is the only difference we do have. But both the functionalities of BCM and board is same. Okay. Okay, just let me erase it. Yeah. So we are setting, the first thing what we need to do after importing the package here is we need to set the mode. So either you can use GPI.BCM or you can use BOARD board. Okay, after doing this, setting the mode, we need to set up the pin, which pin I wanted to use. So I'm going to use 18th pin in order to display the output. So this is what I'm writing, GPI.setup 18. And this is nothing but the status of the pin. What for I'm using this pin, whether I'm using it for input purpose, whether I'm using it for output. So since I want to turn the LED on or off, means I want to output it. So I'm using GPU O.out. In case I want to give input to this particular pin number 18, then it will be something GPIO.IN. So you can see the variations here. Okay, now if we talk about here, while true, let's come into the looping statement. Well, this condition is always true. What is asking you to do? Simple statement, GPIO dot output 18 comma true. So I think you might have understood what we did. True is nothing but 1, the value. We are indicating 1 now. So that value has set. Means what happened here? The LED will be on. And it should be on for 1 second. So time dot sleep. So this will be in seconds. It will, okay, so for 1 second, this particular LED will be on. And after that, what I need to do, I need to turn it off. So GPIO dot output 18 comma false. So what it will do, it will turn the LED off. Then again, time dot sleep also 1 second. So what happens here, it will keep on continuously blink the light. Blink off, on, off, on, off. And it will keep on repeating like this again and again, again and again, again and again, until we are resetting the Raspberry Pi. Until we are resetting this, it will keep on repeating the same thing again and again. So that is what actually happening in this. Okay. Now you people might be confused related to pins when I explained that. Okay, sir, how to determine, how to know which are general purpose GPIO pins. We are somewhat confused. Which are power pins? Which are something called as grounded pins? Which we can use it for meso serial, serial communication, which means we can use it. Well, I have a small diagram here. You people can remember this with the help of this. I think with the help of this particular thing, it will solve your problem. We know that a Raspberry Pi generally have 26 pins. And among the 23 pins, you can see all the yellow color pins, whatever you're seeing here. It is something 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that till 26. Now among the whatever the yellow color lights you people might be seeing, those all are general purpose input output pins. You can use any one of them. Like for example, I have used 18 here, right, in the program. So this you can say it is a general purpose input output pin. It's not necessary that you have to use the same pin. You may use other pin also. You can use 12, 10, 8, 7, 5, 6, 3. That is up to you. Which one you wanted to use, that up to you. But whereas coming to the grounded pins, if you want to find out, the black ones, 6, 9, 14, 20, and 25 are the grounded pins. And whereas coming to voltage, we supply two different type of voltage. We know that Raspberry Pi 3.3 voltage, 5 voltage. So 3.3 voltage you can supply either using the pin number 1 or using a pin number 17. But whereas coming to the 5 voltage, you can do it either using something called as second pin and fourth. So these are nearby. But whereas coming to 3.3 voltage, it is given a very little bit far here. First pin and 17 pin for the power of 3.3 volts. And if you wanted to go for 5 volts, you can use either second volt or fourth pin. I mean second or fourth pin. So with this, I think you people can have an idea. You just paste this in your mind. It should be in your mind so that you can determine which pins I can use it for general purpose input output. If you want, you can use something called 15 as a output pin. So instead of 18, you can write 15. No big deal. Even you can write 24 or 22. That's up to you people, whichever you wanted to take. That's your choice, whichever you want to use it. Okay, so I hope it's very clear till here. It's very simple programs what we have. So if you people are having Raspberry Pi and if you have all the components, you people can try it on your home at your home. Because it requires a power of 3.3 volt means nothing but using a USB cable, you can provide a connection. And with the help of your laptop. And remaining is everything up to you. You'll install the Raspberry Pi software as I told you 9x, how to install it. And after installing, automatically you can execute the program. Okay, let's take another program. Now this program is somewhat, I think you people will like it. This is same, similar to your the previous program what we have discussed, but there is a small variation here. What the variation is, we use a switch. Earlier we did not use any switch, but now we are going to use a switch. So whenever you are turning your switch on, the LED should be on. If you are turning your switch off, your LED should be off. So this is what we are going to do in this particular diagram. Okay, I mean in this particular example. So let me show you the circuit diagram first and then we will see the remaining part. Yeah, see here. So I think you know this is your Raspberry Pi. Okay, I'm writing a shortcut here, Raspberry Pi. And here is a switch. This is your switch. And this is your LED bulb. I told you LED bulb, it's a small bulb what we have. And we are using resistances here. This is what we use resistors. So why we are using resistors here is nothing but See, if you are not using this resistors, what happens? The capacity of this particular bulb, means the voltage capacity of this particular bulb is by default is 1.4 volts. But whatever the power you people are providing is something 3.3 volts, the minimum, as per the Raspberry Pi. We have 3.3 volt power and then we have 5 volts. So what will happen if you are not using this particular resistor, then automatically this particular bulb will be getting 3.3 volts of power. But what is the capacity of this 1.14 volt? So it is much more higher than what is the capacity of this particular bulb. So there is a possibility that this particular bulb may blow off. So that's the reason we are using resistor. Resistor, what it will do, based upon the capacitor of that particular bulb, it will do is, it will provide only that much power to it. Remaining power it will consume on its own. Okay, so that's what we are doing exactly in this particular thing. Something we are using in our system, something we basically use for refrigerators, regulators. I don't know how many of you know that. Regulators. For TV also we use regulators. Why? Whenever there is a fluctuation of power, so automatically what happens, if you're not using this regulators, then definitely this TV, if high voltage is coming, the TV may not be able to hold that capacity and it will simply burn. Same with your refrigerator, if you are using, it will simply blow off. Okay, so that's the reason we use regulators. Same way here, resistors are acting as a regulators in this particular scenario. For resistors, we do have to use it. If you're not using it, then definitely there is a possibility that your bulb may get what we call heated up and finally it may blow or something like that can happen. Okay, or it may lose its fuse, it may fuse. That depends upon the power, how much we are supplying and all. So here you can see that this particular bulb we are connecting. So one we are connecting. So since here also I am going to use the pin number 18 for the output here, and that pin I have connected to this. You can see here this particular bulb is provided. You can see this is a switch, and here there is a red color line, and this line parallelly I am connecting here. So you can see that this is actually connected to a particular voltage. So what voltage it is connected? It is here given as 5 voltage. This is the power line. And then I wanted to use the 18 na power. So this one is connected to this particular thing called as 18, pin number 18. Okay, let me show you the pin so that it becomes clearly for you. Okay, this is the pin what we have. So you can see this blue color line, whatever you're saying, this is the pin number 18 we are using. And for ground purpose, we are using the pin number 14 here, something ground, because this switch has one of the one connector should be to the ground and another should be connected to this particular bulb. So that's why we are connecting in this way. You can see the black one. Okay, so black one, you can see why this black one is represented here like this is nothing but this is ground. We are using ground. You people know we need to earth it up, or else what will happen? Entire board will get a electric current. So the electricity will pass in the entire board. So one of the phase should be connected to the ground. And whereas coming to the this one, we have connected to a voltage here. So what voltage we are using? Basically 5 voltage it is going to apply. So whatever the what about the capacity of this was 1.4 volts. So see, you can see a lot of differences there. 5, where is 5? 1.4. So that's why we are using this particular resistors. And finally, the output pin we are using 18 as the output pin. Let's see the programmatic part. Very easy if you can understand it. So first thing what we are doing is from time import sleep. Now in the earlier program we used it simply import time, and then we wrote time dot sleep 1. But here what is saying from time import sleep. So from the time package, time library, he is trying to import only the sleep module. What about the other modules? He is not importing it because we want only sleep module from this. This particular time library will consist of multiple what we call modules. Among them, he is going to use only one module. That is what we call it as sleep. So this way also we can write it from time import sleep. This is something like Python. You might be knowing it how to use it. Then same thing, Raspberry Pi, we are going to use general purpose input output library. We are going to bring it up, and this is alias sim created for that to use it. So we need to set the mode, and we are going to use something called as BCM mode. I think you people know we need to set the mode first. Now we have to set up the pins. So basically, I need two pins here now. Earlier, I had only one LED. I don't have a switch. So I need only one output pin. That is what I have used 18. But this time, we people require two pins here. One for the input to pass the current and one for the output to get the result. So here I'm using 25. You can see a 25 is a general purpose input output pin. You can see here this one. Have you seen this? So okay, general purpose input output. pin. Okay, he is using something called as 25th pin here, grounded pin. Okay, ground for purpose he is using this. Okay, and okay, fine, I understood. Okay, what he needs to say exactly here is nothing but we already said here that one of the phase of this particular switch should be grounded and another phase should be connected to get the current so that excess current can be directly transmitted to ground, right? So that is what he's saying here. So that connected to this particular pin, what we have something called 25. So 25 is nothing but it's a grounded pin. So one of the phase we are connecting of a switch, we are connecting to this particular pin. And from here we are giving the input. Then we have another one, something called GPIO dot setup 18 pump. So this is the one we use it for output purpose. What is the initial state of the LED? It is false. The initial state I am placing in false means generally the LED is in off state. Okay. And we are using here a toggle button. Toggle button is nothing but it is like a kind of a switch, but only thing switch means what you can understand is when you know when we can turn on and off. If whether the switch is on and off, you can understand. But this is a toggle button. This is something like a bell ring. Okay, so when you will press button, if the LED is on, it will be turned off. Again, when you press the button, when the LED is off, it will be turned on. That is what we call it as toggle button. So in this, we are getting the pin here, the pin number. So initial state is no state, and then we are providing the output. So this is the logic which is actually going to execute your program. So if GPU.input 25 ground pin is equal to 2 means the current is passing, then toggle LED pin means you are switching on the button. So automatically whatever the state might be that will be transmitted here toggle pin, and based on that it will be transmitting, I mean it will output the state. So whatever the state might be, initially for example the pin is on. So you are sending it no statements, it will be turned to off. Then you are displaying the output. So if the LED is on, it will be turned as off. But in case if the LED is off, initial state it is an off state. So we are transmitting here means the state is off state. So no state means it is a reverse of your off state. It will be turned on, and then you are displaying the output. So LED will be turned as on. So this way, whenever you are pressing the button, this particular thing. Until what extent it should work here is 0.01 second only that should work. Okay, after that it should be repeated again and again. This will be repeated again and again automatically. Okay, and whereas coming to this, this is an exception. Since we are using something called as try here, definitely we have something called exception. So what can be the possibility here? Keyboard interrupt. So if there is a keyboard interrupt is there, then we are going to catch the exception here. What is the output you should get with based respect to that is nothing but exit. Means it will, as I told you, this while loop will keep on executing it, right? But whenever you want to come out, you can simply press the keyboard button. Automatically it will come out of that particular loop. It will stop functioning. For that purpose, we are using this particular scenario. So it's very simple program. If you have the components, you people can execute them into your home itself. The circuit is given to you and the programming logic is given to you. It's very easy. Remember, pin number 25, we are using it for the ground purpose here, GND ground. Okay, so the toggle button, one connection will be given to ground and another connection will be given to that particular LED. And the next one is 18. 18 is the one which is connected to the LED. It will produce the output. Okay, so this is the way how you people can execute it. I hope it's very clear till here. You people might have understood how it works. Let's make it more interesting. Let's make it more interesting using something called as sending an email using a Raspberry Pi board. It's something interesting. I'll show you. So what we are going to do exactly here is we are going to send an email, okay, to your friends using by the switch prism. Whenever you're pressing the switch, automatically from the Raspberry Pi board, okay, we have operating system there. Net connection is provided. It will automatically transmit a mail to your friend. So for that, we are going to write a program using Python here. Now, this is the program what you people are going to see here. The first thing. Now here, before explaining this, I want to say that since we are sending an email, we definitely require a protocol to send an email. And we know that what protocol we need to use. SMTP, simple message, mail, simple mail transport protocol. Okay, simple mail, not SMTP, it is STMP. There's a confusion here. Sorry, it's my mistake. So we are going to use something called STMP protocol, which is comes from your application layer. In an application layer, we use it. I think you people know that. Okay, STMP layer. So it is nothing but simple transfer message protocol. In that way, you can remember. So here we are using that particular library here, STMP library. And apart from that, I think these two you people are familiar now. By this time, you should be familiar from time import sleep. So we are going to sleep for a certain amount of time. And after that, again, it will start transmitting the data. Same, and next we have something called import rp.gpo as GPIO, general purpose input output. And apart from that, we are using something called from system import exit. This is something like, whenever you want to exit from the system, we have to import. So we are importing that particular module, exit module. And this module is coming from the package called as SYS. Now, whatever the structure you're saying, this is most important here. So basically, whenever you want to send a mail, how you actually send it up? So basically, you need to give the name of a person to whom you want to send. And that's what we are doing here. First thing what we have is from email, means from whom we are transmitting. This is nothing but this is our email ID. Our email ID where we are going to transmit it. And what about the recipient list is nothing but to how many members you want to give. Well, this is general syntax he has given. If you want to give it, you can give it something like that. Okay, let me write it here, like xyz dot google.com. Then if you want to send another person, abc.google.com, so on. In this way you can write it up. Okay, sorry, in this way within the brackets. You don't require this greater and lower brackets. This is only a syntax he has given that this is the way you need to give. And then CC list. I think you people will have a CC list or CC also there. If you want to give it a CC list, you can write the recipient name there. And finally, subject. You have a subject here. So subject, I am giving it as hello. Then coming to the message here, we are writing message here, switch pressed on Raspberry Pi. Means I am sending a message to so and so person saying that button or a switch has been pressed on a Raspberry Pi. This is the mail I want to transmit it. But before sending a mail, I need to log into my account, right? So definitely I need to give a username and password. That is nothing but xyz.gmail.com, whatever it is. That and the password what it is, that we need to give. And since we were discussing, as I told you that we are going to use SMTP protocol here, right? SMTP, Simple Mail Transfer Protocol. So this protocol we need to use, and this 587 is nothing but, this is a port number. This is a port number. Well, basically we do have two ports here, 587. Either you can use 587, that's the default port number, or we can use 465. So these two ports belongs to SMTP Gmail. Okay, so gmail.com. So SMTP is a protocol, and within this protocol, I am using a module called Gmail. So I can only send a text message. Remember, I cannot attach any document. You're getting my point? And I cannot attach any kind of document. I can only simply send a text file. Sorry, text. And the text is hello, switch pressed on Raspberry Pi. That's it. I can't upload or attach any kind of files to this, because from the SMTP protocol, I am using only a Gmail module, and Gmail module is meant only for transmitting the text, whatever you have written in the Gmail, but not the file. Remember that. For that only we are using. And remember this port numbers. So either you can use 587 or 465. In case 465 port number used by some other what we call application, then you can use 587. That's up to you, whichever you wanted to use. So this one we need to set up. And then finally, you need to set the mode. I think you people are aware of this. Now this time I'm using input again, 25, pin number 25, I'm using it as an input. Now after this, I need to write a function for sending, right? So how we can do it? So I'm going to define a function here. So this is a function, send mail. Okay, send mail is a function which I'm transmitting, and within this I am having parameters. So what are the parameters I have? From address. I think you people might get it from here. To address list, that is nothing but your recipient list. CC address list. I think you people might have understood easily what do you mean the CC list. From here I'm getting it. Then subject. The subject what I set is hello. The message. What message I'm printing? Switch pressed on Raspberry Pi. So login. Login, I think you people might have understood now. You people want to log in now. So you need to give login, username, password. Then SMTP server. So all these parameters, whatever I said, I'm giving it in a format of parameter here to this particular method. And here I am attaching that to a header. So header equal to from. I think in computer networks, you know about header and message. So header will, I think you people know now when we transmitted a network, we have a head here, message, tail. Now you people might have understood this is the head, and this is what I'm setting right now. So coming to the header, what it will consist of from. So from whom we are getting it, from address. Then we are transmitting to whom. So to address. So if there are multiple people, we simply write join. So multiple addresses can be joined together. Now CC list, if there is a CC list, same process, only parameter will change here CC in place of two. Then finally, I'm going to attach something called as header, I mean subject, and along with the subject, message equal to header plus message. On this entire message, I'm placing it. So this means, I mean message plus header I'm attaching. Tail, if you want, you can attach, and this I'm calling it as message, and that message is this. Now this message I want to send it up. Now how I can send it up? This is the code here. Server equal to, now first I mean the server equal to SMTP. Okay, simple mail transfer protocol library dot SMTP. So this is a module which I am getting it from the library called SMTP. And what is the parameter I'm using here? SMTP server. Where we have written this? Here, this one, server. So we are getting that particular parameter here. And then server dot start TTLS. This is something like we are initiating that server. We are switching on that particular server in Raspberry Pi. Then we are giving server dot login. So the username and password is given here. So you're logging into your Gmail account using a Raspberry Pi, and within that we have an operating system called Raspberry Pi operating system. And then finally problems equal to server dot send mail. What is the problem here? We need to send a mail. So whom we need to send? From address, your mail address to whom you want to send it up, and finally what is the message you want to send. Finally server dot quit. So this is the entire function for creating a message, this particular message, and transmitting that particular message. So this is a method we use, server dot send mail. So whenever you're pressing on a button on your hardware device, automatically internally the Raspberry Pi will transmit. So initially whenever you're pressing a button, this particular function will be initiated, server dot send mail, and it will keep on transmitting the message. Whatever you have created here, that will be transmitted to the list of people you are given. This is what actually happens. Now this has to be repeated continuously. We did not write a for loop, right? It should keep on continuously exist until you are interrupting it. For that we have a while loop here. So this is compulsory, then only we can execute. While true, while the condition is true, means this condition will always true and it will keep on repeating. Now we are again using a try and catch here. Instead of catch, we use exception here. So try if GPIO.input 25 is equal to true. What does that mean? If that particular pin 25 is set as true, means it is ready, means whenever you're pressing a button, it will be set as that particular pin will be set. This is the input now. You're pressing the button means what you're doing, you're giving an input. So whenever you're pressing a button, this particular pin, we have connected that particular button to pin number 25. So whenever you're pressing that particular button, it will try to transmit the data. So it will, what is saying, if it is true, send the mail. So to whom we need to send the mail? From email, receipt list, and remaining parameters same, you people can understand. And wait for 0.01 seconds. After that, again, you try to find out whether this is true or not. In case you are not pressing the button, it will not send the mail. Again, if you are sending the button, it will send. And after 0.01 second, it will keep on observing whether you are pressing or not. And if you want to stop this particular whole process, keyboard interrupt. I mean, okay, nothing but press any key value from keyboard. So it will immediately interrupt you with this particular thing. So this is the way how you people can do it. It's very easy. You people can even try it at your home if you're having a Raspberry Pi module. Okay, this one you can try it up. You don't require any hardware. Only the switch and connection, small connections are required. That you can see in the previous slide what I've shown, and based on that you people can process it up. Okay, now the last but not the least, what we have here is nothing but using LDR sensor. Okay, LDR is nothing but something we call it as light density. Okay, LDR basically we call it as light density sensor here. So what is the main purpose is based upon the intensity of the light, this particular means this particular sensor will read. If the intensity of the light is low, it will turn the LED on. If the intensity of the light is high, it will turn the LED off. Okay, so this is what we call it as LDR sensor. So without wasting time, I'll show you. This is a circuit diagram for your LDR sensor. You might have seen it. So here, just give me a small flash over here. This is what we call it as LDR sensor. It's a very small one. And here, this is what we call it as a capacitor. Capacitor required because this is the one which generates power. Okay, and that power will be given to this particular sensor. And if there will be a threshold set for this particular sensor, okay, LDR, if that whatever the temperature is, I mean whatever the light intensity is measured, if it is above that threshold, this LED will be turned off. If it is less than that, this LED will be turned on. So this is the way how it exactly works. Okay, so you people can try this. I will show you the programmatic part. How we can write. See here. Okay, so you can see the first two are the nothing but the packages what we are using here. You know very much familiar. I'm not going to explain them again. So set mode is done. Now this is what I was talking about, LDR threshold. Now I am keeping the intensity of the light as 1000. So if the value of this particular LDR sensor is less than suppose 999, then L means the light intensity is very less. So the LED will be turned on. If this particular LDR is having 1001, whatever the measured sensor, the threshold is 1001. So it is greater than 1000. So definitely the LED will be turned off because there is a huge light there. So we don't have to turn on the LED. So this is the way it automatically works. So here we are going to use some 3 to 4 different type of functions here. The first function what you can see here is read LDR pin. So here from here we are going to read the intensity of that particular light. So for that we are initializing the reading variable as 0. So I am first have to set up the pin. Which pin I wanted to use. So if you see here, I am using a pin number 18, LDR pin and light pin. So LED will be connected to this particular pin number 25, whereas LDR pin is connected to the pin number 18. You can see this. So whenever you want to turn the light on, the current should be or the power should be passed to this particular pin 25. Because to this we have connected this light pin. Okay, LED pin. I'm talking about this one. LED pin. So here I'm setting it up light pin comma GP output. So which one is giving the output here? Definitely this 25 is going to give the output. So this one light pin comma GP IO dot pin. Okay, and this light pin is nothing but this one I have written here. Then GPIO output. So output initially what we had to do, the LED should be in a false state. So pin comma false. So initially the output is false. It should not start. First it has to measure the intensity of light. Based on that it has to decide whether it should be turned on or off. Then we have time dot sleep 0.1. So after every 0.1 second it will keep on repeating the task. Then we have setup for input. So after 0.1 second, it will set up the input here. So input, I think you people know LDR pin, what we are using it here. So if that particular, so while the condition is true, it is asking you to read. Read means what happens to the intensity of the light, it will keep on reading. So basically what is happening here is, the LDR sensor will keep on reading the data. Means if the intensity of the light, it will keep on reading every second, every 0.1 second, it will read. And if there is an increase in the light, it will increment the value of reading. Initially the value of reading is 0. So then it will become 1, 2, 3, so on up to 1000. Okay, if it is less than 1000, then LED will be turned on. Maybe it is a night time. But if it is a daytime, definitely the value of this particular thing will increase. Maybe 1001, 1002, 3, 4, 5, maybe 2000, something like that. So definitely it will not be turned on. In case if the light is turned on, it will be automatically turned off. This is the way how it exactly works. It's very, very nice. If you can implement it, that is much more better. You can, you will find the intensities and all. This is the way how we actually apply to our home automation system. How it is applied means this is the way it is exactly applied. Then we have defined a read LDR. Now we are going to read another one here. Okay, fine. So I have just repeated the same process. Okay, don't think it's both are same. This one and this one are same. I have just repeated the same thing I have. This one I should keep it in comment. I just forgot to keep it. So since I have written this in Python, so I'll be using something hash here, something like this. So this is in a comment because this one you don't have to consider it. Both are same here, the top one and this. So this is what actually happening. And after that we have another function called as switch on light. Okay, and then we have switch off light. So obviously some action has to take place based upon this particular reading. So that is what happening here. So we'll get the pin number here, and we will be setting up the pin here. So whenever the power is increased, means the intensity is less, we are making the LED on. True. I think true is nothing but 1. So we are making the LED turn on. And if you talk about this one off light means whenever the value is more than that, the threshold value is more than that, we are turning it off, 0. False means off. So this is the way how we can do it. And similarly, we need a while loop because it has to repeatedly continue, and this is the statement for that. While condition is true, LDR underscore reading equal to read LDR. So what we are doing, this is a function, read LDR, and this is a pin number, LDR pin. What is the pin number we have LDR pin here? Yeah, here. It is 18. So that pin is asking you to read here. And based upon that reading, if the LDR reading you are doing it, whatever the reading you are getting is less than the threshold. What is the threshold we have set here? 1000. If it is less than 1000, switch on light. From here, the control will go to this particular switch on light and it will simply switch it on. In case if it is greater, LDR reading is greater than that, it will ask you to switch off the light. And again, the control will transmit it to the switch off and it will switch off that particular light. So this is the way how it exactly works. Very easy. See, it will try to read the data. How? Read LDR, LDR pin. So LDR pin, what we have set here, 18. So at this pin number is asking you to read the intensity. Means from this particular, whatever the intensity is, that we are transmitting to 18. And if the value, whatever we are transmitting, how it is getting incremented, see, you can see here, read LDR pin. This is what happening. So it will keep on incrementing, +1, +1, +1, so on up to it is until maybe whatever the extent might be. If it is less than, suppose initially it did +1, so we are returning that reading. Okay, input pin is false, it will be reading, okay, reading +1 and it will be returning the reading. Suppose the reading initially we received is 500. It is less than 1000, means it is maybe it is the evening time, so the intensity of the light is less. So what you are asking, turn on the light, switch on the light. In case if it is morning time, then definitely it will be more than 1000, maybe 1002 or 2002, 2005 or 2050, something like that. So this condition fails. So we will be switching off the light. So this is the way how exactly you people can write the programs using Python. This is a Python program we have written using Raspberry Pi operating system. It's very easy, right? So that's the reason we have opted for Python. It's very easy to implement, very easy to understand, and very easy to execute. That's the reason we have implemented it. So I expect you people, if you're having the components with you, you people please try at home using these particular devices and try to see how exactly it works practically. These are very simple programs, and not only that, you can use your own code. You know, in net you will be getting a lot of code with respect to this particular concept. So you can use even that and you can execute and can see how exactly your Raspberry Pi board works using your Python. Okay, so I hope it's very clear with this. Well, this is a small topic we have with respect to your other IoT devices. If you talk about here, okay, we'll discuss this fine in the next class, and then we'll continue with the remaining part 2. Okay, this is the last phase we have. This we'll discuss, or you can just go through it. Anyhow, I have written it represented in this way. Whatever I want to explain, I have represented here. People can just go through this. Okay, these are the other type of boards with respect to your IoT, what we do have. And this is what we are actually implementing. You can use these boards also for implementation depending upon your requirement. So these are also most popular boards what we have. Apart from that, we have Arduino also, but Arduino comes under different flavor. So we didn't represent it here. Here we are actually focusing on your Raspberry Pi, so that is what actually is focusing on. So in the next session, we will try to start the next part of your fourth unit, that is nothing but your cloud services. So we are saying that the information is stored in the cloud. So how the cloud is actually storing? What are the different type of cloud services are provided by different companies that we are going to see here. Okay. Okay, so this is a comparison of your this. Okay, anyhow, in the next session, I will try to compare, take some time to discuss this particular concept and then I'll explain it. Okay, for timing, you can just save it. Understand the previous concept. Whatever I've explained in the earlier related to your programs, please concentrate on the programs and work on it. Thank you. Thank you for patiently watching this video. If you like it, please like it and subscribe. Thank you.